is titled Modeling with Periodic Functions. We're going to do pages 18 through 20. And then tomorrow you guys will, so we're going to do all of that together. There's nothing really for you to do in groups. And then tomorrow you're going to use this to do the next section in your groups. Okay? All right, so up at the top of page 18, we again have a Ferris wheel. You're going to see that one used a lot because it applies to this really well. All right, so round and round we go. A new Ferris wheel has a diameter of 68 feet. Riders board the pod at ground level. So it's 0 on this one, and the wheel moves counterclockwise. Each ride consists of 4 revolutions, and you can assume that the Ferris wheel spins at a constant rate. First thing they want you to do is to create a sketch to model the height of the rider above the ground with respect to the number of revolutions of the Ferris wheel. So this graph is only big enough to fit 2 revolutions and a little bit more. So if you can get at least 2 revolutions here, I mean, if the graph were wider, then you could probably fit all 4. But we need to figure out, based on how tall this Ferris wheel, where it's going to be and when. Okay, so if the total diameter is 68, that means the radius is going to be what? 34, right? Yes? Yes. All right, we also, if there are 8 cars or pods, whatever you want to call them, you're going to take your 360 and you're going to divide it by the 8. That means it's going to have 45 degrees for each, right? That creates 45, 45, 90 triangles, okay? So if the radius is 34, so from here to here would be a 34, from here to here. Anywhere you're going to have the hypotenuse is going to be 34. All right, so we're going to take that 34 and we're going to divide it by the rad of 2. So if you were going on a 45, 45, 90 triangle from the leg to the hypotenuse, you would multiply by rad 2. But if you're going from the hypotenuse to a leg, you're going to divide by the rad of 92. So that means you need to rationalize that denominator. The way you rationalize the denominator is you multiply both the numerator and the denominator by that denominator. So if you multiply by rad 2 over rad 2, you're going to end up with 34 rad 2 over 2, which is going to get you a leg of 17 rad 2. So you're going to keep seeing that 17 rad 2 in here. So each of the legs are 17 rad 2. So this part right here shows where the 17 rad 2 comes from. And then we have to, for each of the locations on here, we have to figure out where it's going to be at. So for the first 45 degrees, we've gone 3/8 of a complete rotation. And that's going to be the cosine. And then we've gone 34 feet up from the ground, plus 17 rad 2 more. And then down here, we would have gone 34 minus 17 rad 2, because each leg is 17 rad 2. Anybody still represent the height of the rider above the ground as a function of the number of revolutions of the Ferris wheel? All right, so as the Ferris wheel is rotating, so 0 is obviously the starting. You're 0 feet above the ground because this one doesn't have any clearance, okay? Major the most obvious ones are like at a half a rotation, you're at the highest point right there, which they said was 68. So half of the half, which would be a quarter, you're at 34, and half of the second half, you'd be at 3/4, which is also 34. So finding the eighths is where we use that that 45-45 triangle. 45-45-90 triangle. All right, so for the 1/8, you're going to subtract the 17 rad 2 from the 34. And for the 3/8, you're going to add the 17 rad 2 to the 34. Okay, so here you're at 9.96 feet. When you go around a Ferris wheel, you're going to hit that same height right before you get back to 0. So this should match this, right? And then these two numbers should match as well, because that's right before you get to the top of the Ferris wheel, and then right after the top of the Ferris wheel, those two heights should match as well, okay? All right. The other piece of information they want down at the bottom is, now let's take a look. Oh, we'll get there in a second. Okay. They are going to have you come back and fill in something called the midline. So the midline, you're going to take the max height plus the low height and then divide by 2. So that's going to be 34 feet. On this particular one, there's no clearance from the ground. It's at 0. But remember, on some of the other ones, it was, there is a clearance, right? So if it was like a 5-foot clearance, you would have to add that, or 10-foot clearance, or whatever it is. Then divide by 2. Amplitude is going to be the max height minus the midline. This one does not specify how long the period is going to be, okay? Some of them will. This particular one does not. All right, anybody still writing? And it got changed in another spot, but it didn't get changed right there. So I'm running a Ferris wheel. Here is what we know about the Ferris wheel. So the Ferris wheel has a radius of 30 feet. The center of the Ferris wheel is 34 feet above the ground. So it's going to have that little 4-foot clearance down here. Okay. And then the Ferris wheel makes one complete rotation clockwise every 24 seconds. All right. They want us to create a sketch to model the height of Mrs. Hoban above the ground with the respect to time. Okay. So this one had 12 buckets or pods, whatever you want to call them. So if you take 360 and divide it by 12, you're going to get 30 degrees. So that creates your 30, 60, 90 triangle. We'll deal with that in a second. First, I'll let you guys draw in the model. Okay, so we do know this, that the radius, and let me zoom in a little, the radius is 30. So we need to get the short leg and the long leg. So the radius just happens to be the hypotenuse. On a 30, 60, 90, you know that to go from the short leg to the hypotenuse, you multiply by 2. So to go from the hypotenuse to the short leg, you do the opposite, which is to divide by 2. So we're going to take the 30, divide it by 2, which gets us 15. Okay? Then you take the short leg and you multiply by rad 3. That gets you the long leg. So you should have 15, 30, and 15 rad 3. Okay? That we need to help us fill in the chart below. Does everybody have that triangle drawn? They want us to complete the table to represent the height of Mrs. Hoban, where she's going around in the amount of seconds. Whew. Okay. All right. So our at 0 rotation, I'm at 4, right? and then in 24 seconds, which let's hope it's minutes, not seconds, I'll be at 4 again. So the max height we determined was 64. That would be at 12 seconds. And then we need to fill in the different heights. So for here, we're going to take the 34 minus the 15 rad 3. Here we're going to do 34 minus the 15 at 4 seconds. At 6 seconds is right. Well, I can't point to the others. I'd have to shrink it. 20 says, to model the height of a rider above the ground, you used a periodic function. Today we will look at some of the attributes of the periodic function. So this is a great little diagram to show you how it's all working. So the amplitude is going to be the max height minus that midline. The midline goes right through the middle of the graph, okay? And once you get back to where you started, that's one full cycle, right? That's going to be the length of the period, okay? And for your amplitude is going to be that it's half the distance between the highest and the lowest points. And it's the distance from the midline to the highest point. A period is usually specified, but not always. It's going to be the horizontal length of one complete cycle. The midline is going to be the horizontal axis of the graph of a trigonometric function. It's going to be halfway between the highest and the lowest points. And then they want you to go back and write them in. We already wrote them in.